So this is Algebra 1, Semester 1. It's a unit called Functions, the 5th unit. And it's a lesson called Arithmetic Sequences Practice. It's lesson number 2. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Just to show you where those notes come from, it's a little bit difficult sometimes for students to find. There we go. So this is the actual name of the website, creatormath.weebly.com. Google that. If you do, you should be able to get to this homepage. If you have any questions on the composition book, please just scroll down, find the words composition book. Please follow all the directions, watch all the videos, adhere to the due dates, put things on the pages they belong, including the notes, which we're going to switch over and find where those are. On the actual tab of the class, you will find 5 things, maybe a little bit more, but 5 things. You'll find all the vocabulary for the entire semester. If you're not getting 100% on the vocabulary, maybe you don't realize there is a PDF that is not only downloadable to your device, but is also searchable. Just Google how do I search a PDF with whatever type of device you're using and follow those directions. Then we're going to find the semester we're in for the one that's relevant to us. In this case, for this video, we're going to go to this one. Make sure you're in the correct one for the work for the semester you're in. This is the table of contents, and the directions are that you should have copied this in its entirety onto pages 2 through 6 of your composition book. Why? Because it lays out all the page numbers of where everything goes for the entire semester. Now we're going to go ahead and find the unit that we're in. There it is. In this case, it's functions. We're going to look at the lesson within the unit, which is number 2, arithmetic sequences. It's on this page numbers. Here's where the notes go. Please don't take this video's word for it, but go back and find the table of contents. At the time you're watching this video, these page numbers probably will have changed. In fact, all of them will have. Here are the notes, the problem sets, the video solution will be here, and we're going to click notes. Fair warning, sometimes it takes me a couple times to open these notes. In this case, it did brighten up on the first try. So they're talking about different things right off the bat. They're talking about discrete points on a graph. Discrete points are individual points. These are discrete points because they're individual. All right, continuous, talking about the idea that a continuous function, we put our pencil down and we draw, and we do not lift the pencil until we're done. Then we lift. If at any point in the middle of this we lift and have to then put it back down to continue the function, it won't be continuous anymore. It'll be discontinuous. All right? So an old concept for us by now is linear or line. It's a graph of line. And then it's important for students to note there is the opposite of a linear graph, which is a nonlinear. And another name for a nonlinear, sort of generically, is a curve, right? So a curve like this is a nonlinear graph. Pretty basic concepts in this lesson so far. So we have linear function, nonlinear function, discrete, continuous. And with that, let's go and see what the problems are for this lesson. So identify the following graph. This looks like those discrete points that we saw in the notes. So discrete points, and they're explaining what it is to us, individual points, right? That's true for this case. Sometimes math vocabulary makes sense. Not always, but this time it does. Identify the following graph. This would be continuous because we put down our pencil and we draw and we don't ever lift up our pencil. That would be a continuous graph. Infinite set of points. What does that mean? So what is a graph composed of? It's composed of a bunch of points. How many? An infinite number of points. And I'm drawing a space between each one, right? But imagine that I could draw these so small and so infinitely where I'm like dot, 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 dot. If I drew enough of them, it would look like a line, or in this case, not a line, but a curve. Okay, so an infinite set of points, continuous. There's no point where the pencil is lifted. So some big concepts about graphing and graphs that sort of take students to the next level. Identify the following. Let's jump back to the old school. This is a line, right? So a linear graph. Linear, there we go, is like linear, right? Linear means line. Oh, I'm spelling it wrong. Linear. Thank you. So linear, right? It's a linear graph. It's got the word line in it. That's how you know it's a straight line. All right. So contrast that with the opposite of a linear graph. Right? Would be a nonlinear or a curve. So it is important to note, and this is a little bit off topic from this lesson, but remember, if we have a circle, right? A circle is not a typical graph. Why? Because if we cross through this thing, for every x value, there's more than one y value. This would be called a relation. It's not a function, it's a relation. We can draw a circle, but it's not a function, it's a relation. So we won't deal with it much. Now, how do you take a relation and make it into a function? Cut it in half. So say I just had this, half a circle. This is a function, because for every given x, there's only one y. All right, and that's back to another topic we've already covered, but just to sort of bring it in discussion here, a little bit relevant in terms of compare and contrasting. So given the following arithmetic sequence, 1, 5, 9, 13, 17, ... what is the difference between each number? What's the difference between 1 and 5? 4. What's the difference between 5 and 9? 4. What's the difference between 9 and 13? 4. What's the difference between 13 and 17? 4. Notice the difference between each of these is a consistent number. This would be called an arithmetic sequence. Okay, so the difference between each term is 4, and each of these are called terms. All right, this would be called the first term, or sometimes zero term, and the zero term, and then this would be called the nth term. So oftentimes the nth term is nth minus 1, etc. We'll see that in a minute. Right? We'll see some examples of that as we get deeper into these. So given the following arithmetic sequence, what's the 8th term? So this is interesting. So first of all, what's the difference between this one? 3. What's the difference between these two terms? 3. What's the difference between 7 and 10? 3. So imagine this. We've got 1, 2, 3, 4. What would be the 5th term? The 5th term would be 13. What would be the 6th term? 16. The 7th term would be 19. Okay. And the 8th term, there we go, is 22, right? 3 plus 19 is 22. So what is the 8th term? 22. We just drew it out, but let's say it's something large, right? Let's do a calculation. Well, the 8th term, 1, 2, 3, 4, 5. So we're at 4 here, and we're going to go on up to 8, right? We want to go 4 more from this one. 4 times 3 is 12. 12 and 10 is 22. So we can do a little calculation, given we know what the number is between each term. We can just project out ahead and do that calculation that the 8th term is 22. Therefore, we could do the 100th term, right? Just do the same thing. If 4 is 10, then 100 minus 4 would be 96 more terms. 96 times 3, right? 96 times 3 is 288. All right, so 288 would be added onto the 10, and you get 298. That would be the value of the 100th term. Right, so we can just project out for each one in an arithmetic sequence. Given the following arithmetic sequence, now it's negative. Negative 3 to negative 5 is it's down 2. Negative 5 to negative 7, down 2. What is the difference between each term? Negative 2. If the first term and common difference of an arithmetic sequence is 3 and 2, so here's the first term, 3. Then the 12th term will be, so this is 1. The next term is we're adding 2, 5. The third term is 7, etc. If 3 and 12 are how far apart? 9 more. At 2 difference, 9 times 2 is 18. And this is already at 7. 7 and 18 is 25. So by the time I get to the 12th term, I'm going to be at 25. And I don't have to write all the 12 terms out, right? I can just do a little calculation of where I am to where I'm going, plus what I've already got. Well, so make sure you're matching up the title of this video with the problem set you're doing, otherwise it won't make much sense. This is Algebra 1, Semester 1. It's a 5th unit called Functions, and it's a 2nd lesson called Arithmetic Sequences Practice. It's on creatormath.com under the Algebra 1 tab. Hope this helps.